You walk outside one night, and something is wrong with the sky. No haze, no clouds, no moon. Not shattered, not eclipsed, just missing. This is Paradox Lab, and here's what would actually happen if the moon suddenly vanished. First thing, you don't get Hollywood destruction. No instant earthquakes, no buildings ripping apart. Gravity doesn't turn off. Earth still orbits the sun just fine. But the moment the moon disappears, one thing changes immediately: the tides. Right now, the moon is the main reason the oceans rise and fall. Its gravity pulls the water into two giant bulges on opposite sides of the planet. When the moon vanishes, those bulges don't politely fade. They collapse. High tide levels drop worldwide. In some shallow coastal areas, water pulls back and never reaches as far as it used to. Mud flats that were covered twice a day are left exposed for much longer. Animals that evolved to live on that rhythm of flooding and draining, crabs, shellfish, seabirds, coral reef life, suddenly get hit with a new, harsher timetable. The sun still creates smaller tides, so the ocean doesn't become a flat, static bowl. But tidal ranges shrink. Storm surges and coastal erosion patterns change. Estuaries, deltas, and tidal marshes, some of the most productive ecosystems on Earth, start to slowly break down. Next, planetary stability. The moon is like a stabilizer on a spinning top. Earth is tilted about 23.5 degrees, and that tilt gives us seasons. The moon's gravity keeps that tilt wobbling only a little over long timescales. Take the moon away, and over tens of thousands to millions of years, Earth's tilt can start to wander much more. Some simulations suggest it could swing between almost upright and over 40 degrees. That's not a tomorrow problem, but it is a deep time climate problem. A bigger tilt means more extreme seasons, roasting summers, brutal winters. Ice caps advance and retreat more violently. Regions that are temperate now could turn into deserts or permanent snowfields in different eras. Human civilization, agriculture, and coastlines are all built on the idea that climate wiggles but doesn't slam from one extreme to another too fast. Remove the moon, and that assumption gets weaker. Now, the night itself. With no moon, nights become truly dark. The Milky Way becomes far more obvious. Astronomers would celebrate a naturally darker sky every night. But for wildlife, it's chaos. Millions of species use moonlight as a clock and a compass. Sea turtles, insects, migrating birds, nocturnal predators. Suddenly, there's no full moon nights, no lunar cycle at all. Animals that time reproduction, feeding, or navigation to the brightness and phase of the moon would be thrown off. Some would adapt, others wouldn't. On human timescales, Earth's orbit around the sun barely changes. We already move around a shared center of mass with the moon. If the moon disappears, that center shifts slightly closer to Earth's center. The change is tiny compared to our distance from the sun, so we don't go flying out of the solar system or spiraling into the sun. Orbital mechanics notice it. Your daily life doesn't. Psychologically, though, that's where it hits fast. For as long as humans have existed, that cratered disk has been up there, guiding calendars, steering tides, inspiring myths, stories, religions, and science. Eclipses vanish. Once in a blue moon stops making sense. Whole cultures lose a built-in clock they never had to plug in. So if the moon suddenly vanished, you wouldn't see the world explode. You'd see coastlines slowly redraw. Ecosystems unspool. Nights get darker. Over deep time, climate gets stranger. And every time you look up at that blank patch of sky, you'd be staring at the missing piece that quietly held Earth's rhythms together. We don't notice how much we depend on something that feels normal until the moment the universe takes it away.